Good day to everyone. This day we'll be talking on hypothesis test for variance. To start with, let us again define different learning objectives that each of you must be able to attain by the end of this lesson. You should be able to identify the different R functions used to perform the hypothesis test for variance, and you should be able to perform the hypothesis test for variance. Make sure you have with you these materials as we go along. So what does a variance tell on a given data set? Any idea? Suppose that you have grades, grade 9 Ruby and Garnet, and you have obtained a variance of 33.66 for Ruby and a variance of 34.75 for Garnet. Is there a significant difference in their variance? Why do you say so? Okay, so this day again we'll be talking on comparing the variance for two different groups. And then in order to do this, we'll be using these two important statistical tools used to perform hypothesis tests for variance, which are the F-test and the Bartlett's test. And then again, these statistical tools are used to determine whether the samples are drawn from a population with equal variance. So we are going to check whether the data have equal variance between the two different groups. And then this hypothesis test will compare the variance for two or more samples to determine again whether they are drawn from populations with equal variance. And then to start stating its null hypothesis is that the variances of the two groups are similar, and its alternative hypothesis will be they are not equal. So since we said that our null hypothesis should always state equality, hence we say that the variances of the two groups are equal, and then our alternative hypothesis always follows a pattern that there should be a difference between the two groups. Hence we say that the variances of the two groups are not equal. So to perform the hypothesis test for variance for stock form of data, this is also the use of F-test. To perform the F-test, we'll be using the function var.test. Again, this is our function used to perform the F-test for hypothesis test for variance. Then you have there your values, then followed by your grouping variable. So you have to identify the values or the variable which corresponds to your data set, to the actual values from which you are going to compare their variances. And then you also have to identify the name of the variable which corresponds to your grouping variable, and then followed by your data set in which you are going to pass. Okay, so if your data is encoded in Microsoft Excel, try to save that one as CSV file format, and then after which try to import the data or try to import your CSV file format to your RStudio so that we can perform the data analysis. Now, if the grouping variable has two or more levels or two or more categories, then you must specify which two variables are you going to compare. So like this one, if that happens, you have to indicate the two levels of, or the two variables, or the two categories from which you are going to perform the hypothesis test for variance. Pass in there the variable for your values, pass also your grouping variable, then your data set, then identify the group from which you are going to perform the hypothesis test for variance. Then this is if you are using a stack form. For unstacked form, in a stack form, you are going to pass the name of your data set in which you're going to perform the data analysis, and then pass also the names of the variable in which the hypothesis test for variance will be conducted, just like stating data set and then sample 1 and sample 2. These are our variables that we wish to determine whether there is a significant difference between their variances. Now, for example, we have here this problem. We want to use an f-test to determine whether the variances of sepal width is the same for the two species of iris dataset. A significance level of 0.05 will be used. So in this given problem, we are to test whether the variances of sepal width is the same for the two species of iris dataset. Now again, your iris dataset is a built-in dataset to R from which we can perform the data analysis. So there's no need to encode the data because this data is already installed into our R the moment we install RStudio in our computer. So to do this, we'll be using the f-test. So for f-test, we use again the var.test function to perform the data analysis. And then since our iris dataset is in stack form, we are going to pass in here the variable containing the actual width of our iris dataset, which is your sepal.width variable. And then our grouping variable here is our species. Okay? So again, this is our grouping variable, and this is the actual variable which holds the values of the sepal width. And then our data set here used is the iris data set. And then since our species contains 3 categories, we need to specify which category of species are we going to perform the hypothesis test for variance, which in this case are the versicolor and virginica species of your iris dataset. Now iris is actually a flower, so these are the two species of iris flower. So in this case, again, we are going to compare now the variances between versicolor species and virginica species for iris flower dataset. So after performing the data analysis, the most important part that we can take a look on the output or the computer generated output is our p-value. Our p-value will guide us whether we are going to accept or reject our null hypothesis. Since we now have the computer generated output, you can now proceed with stating we can now proceed to performing the hypothesis test for variance, which will of course start with stating our null and alternative hypothesis. So to do this, our null hypothesis should state that the two variances are equal. Hence we state that there is no difference in the variance for the sepal width of the two species of iris dataset. So mean to say, the variances of the two species are equal, and our alternative hypothesis states that there is a difference in the variances for the sepal width of the two species of iris dataset. So again, it is a statement of inequality. And then, as stated in our problem, the level of significance used is 0.05. But then again, if the problem doesn't specifically specify the level of significance to be used, we can further assume that it is using 5% level of significance. And then, from the computer-generated output, we are going to extract the p-value, which is from the output presented earlier. It is equal to 0.849. Now, if we're going to compare the p-value and the level of significance obtained, the p-value obtained is of course greater than our level of significance. Hence, we accept HO. And then since we accept HO, we can therefore conclude that there is enough evidence to conclude that there is no significant difference in the variances of sepal width for the two species of iris flower. So in this case, based on our data set, we could conclude that the variances of versicolor and virginica species of iris flower have the same variances for their uh, sepal width. So the difference is not really significant in that case. So again, the variances of the two species of iris set is not significant. Hence we said that there is no difference in their variances. Questions so far or clarifications? Now, again, aside from F-test, we also have your Bartlett's test, used to perform hypothesis test of variance. Again, for the F-test, to perform the data analysis, use the Bartlett test function. Now, for Bartlett's test, the function used to perform the Bartlett's test is Bartlett the test function. Okay? Name of your function, that's the Bartlett dot test, and then again your values from which you are going to compare their variances or the actual value in which the variance will be computed, and then you are also going to pass your grouping variable followed by your data set, again if that is a stack form of data. So in a stack form, again the data for two different groups are combined in one column. So there are only two columns shown in the stack form, which is your actual value, and then you also have a column for your grouping variable. So unlike F-test, your Bartlett's test allows you to compare the variances of two or more than two groups. But then, however, you can still select a subset of groups to compare. For example, you can determine, okay, you can compare the variances of group 1 and group 2 from your data set. So more or less we have the same format when using the ftest function. It's only that the function name is being replaced from var the test, it is being replaced to Bartlett the test function. Now, if your data is in a stack form, I mean to say the sample are in separate variables, nest the variables inside the list function. So this is how you are going to perform your Bartlett's test if you have a stack form. Your Bartlett the test function to tell R that you are going to use the Bartlett's test, and then pass in there your list function, then your data set to be used to, and the variable you are going to compare its variances. If you have more than three, you can place them side by side. Data set sample 3, sample 2, and sample 1. Okay, for example number 2. Suppose that we want to test, we want to use the Bartlett's test to determine whether the weight variance is the same for all treatment groups of our plant growth data set. So, okay, so in our uh, this is our plant growth data set. It has treatment variable which correspond to the group, and then we also have your weight. Okay, so in this case, since you are using the Bartlett's test statistical tool, you are going to pass your Bartlett the test function, then the variable from which the variances will be computed, which is our weight, and then our grouping variable here is group, and then the data set to be used is plant growth. So when you press enter, it will display this output. So from this output, try to take a look on your p-value. So if you know how the p-value, you are now ready to perform the hypothesis test for variance, which will start with stating your null and alternative hypothesis down to stating your conclusion. So again, to perform the hypothesis test, state your null hypothesis. Our null hypothesis states that there is no difference in the variances of the weight for the three treatments. So there are three levels of treatment for our grouping variable, for our plant growth data set. T0, T1, and T2. Then our alternative hypothesis will state that there is a difference, the variances, of the weight for the three treatments. Again, our general concept for our null hypothesis is a statement of equality, while our alternative hypothesis is a statement of inequality. And then our level of significance to be used is 0.05 since it was not explicitly defined in a given problem, then we can assume that it is using a 5% level of significance. And then from our computer generated output, you have to take a look on our p-value and then try to compare the p-value obtained by the level of significance used in your study. So if our p-value obtained is greater than our level of significance, therefore we can accept our null hypothesis. So in this case, our decision is to accept our null hypothesis since again, the p-value obtained is greater than our level of significance. Therefore, we can conclude that there is not enough evidence to conclude that the variances of the weight for the three treatments significantly differ. So more or less, the difference between the variances is not significant. So why do we need to perform the hypothesis test for variance? Now, one important concept in performing the in comparison of three or more means for three groups or three or more groups is is to gain understanding on the test for variance because your analysis of variance makes use of F test. Okay, so your variance will tell how scattered is your data. So the lesser the value, the less scattered is your data. So I mean to say, if there is no difference between the two groups, more or less the two sets of data are homogeneous. But then if there is a significant, if the difference is significant, therefore we could say that the two groups being compared are heterogeneous. Their data differs from each other. Okay? Questions so far or clarifications? Okay, so if there's none, thank you and have a good day.